A while back, someone asked about debuggers, hardware debuggers. These guys right here. I have a collection of them. So I decided to get started on trying to run one. So what we have here is the PicoProbe, and we have here a Pico. And it just happens to be sitting on this breakout board so I can easily do the jump ring and stuff like this. Because this Pico I had put the debug pins pointing downward. Um, I could be putting them upward also. I had another one around here where I did that, or out the side. But I have another board here, for example, I could do it right here too. So to begin with, first I had to learn how to do this. So they give you some cables, a USB cable, which I'm not using at the moment in the box. So this thing right down here, that red one. But the other three cables um, they gave me. It's also important to note we're going to look at this tab again in a bit. So this guy here is a JST to JST. Now, I don't have the Picos to have the JST here at the end. Normally it'd be like that. That's actually the Pico H. Has that already on it. So all I have is actually pins. So this cable was actually a bit useless. But the other two are useful. So one of these guys is standard pins male. One is actually standard pins female. And I've got the female ones hooked up to what they call the debug port. You can actually take the shell off, like so. So this is the debug port right there. This is the UART port. And this is power and communications today. Now, in essence, this little guy here is actually basically one of these without all the header pins. So I'm just going to put my top back on again. Now, which means that if you actually hold the boot select down on here and plug the cable in, you'll get that RPI folder for putting a UF2 file in. I actually blew this up, and I'll describe how I blew it up. Meaning that you don't have to actually buy this. You can actually take another Pico and turn it into a debug. So there's a special firmware that you can get that is in the what's it called? Oh yeah, the Pico SDK blob, and it's for doing the Pico probe and the Pico debug. So this is the probe, and if you do it on here, it's the debug. And if you put that Pico debug UF2 file on here, you effectively turn this into one of these. Okay, and you'll see pictures, diagrams. I'll show you in a minute what they are. Now, one convenience of this board is if I hold my run key down over here, and then I hold this key down, let go of the run, and let go of this, I get effectively the RPI without unplugging the cable all the time. So, which is handy. Now, I decided to first of all do it the Raspberry Pi way. So we were going to go and set up, and I was going to do it in Visual Studio Code, which I did. But you have to add a bunch of things to Visual Studio Code. So one of the first things we have to do is go get documentation. Now, this place here, Circuit State, tutorials, um, they have a whole pile of them in here. I first started off with the tutorial, how to do the Pico, and let me just find that particular page. Oh, I might have closed it by accident. Just a sec. History. Just give me a moment here. I just have to find what I was looking for. Is this the same? Yeah. So I started on this one. Projects using Raspberry Pi, debug, probe, and VS Code. Now, one of the things they recommended early in the reading of here was setting up for a making a project. So this thing goes through the whole thing, right? Pinouts, the whole 9 yards, right? And I read through it, right? Blah, 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 blah. And it's Windows oriented. But what I needed to do first really was back step one and learn how to actually compile and build a program for this and upload it. So I went back to this one. How to compile Pico SDK projects. I didn't need to do it in Windows. It just so happens I ended up on Windows. But I just ignored the actual window paths and just substituted the Linux paths and everything. So one of the first things you have to do is when you're creating a Pico project. Now they go on here and they gawk you through here. And one of the problems, of course, I found right away is I need to backtrack again one more, which was getting started with Raspberry Pi Pico, which is this big PDF here. Just a sec, I actually already have it open here. So this guy. So yeah, it's like 2 steps forward, 1 step back type idea. You read through all this and they talk about a lot of stuff and blah, blah, blah. But what I was really after all the way down into here is the first few sections. Not the application per se, right? But how do you build it? And once I saw this in here, the CMakes, I realized that we have to have the CMake infrastructure. So what I did is I went back to Visual Studio Code to get started on this. And I created a new profile. And I called it PD Pico Debugging, so that I would have all the correct parts in it. And I double checked my extensions to make sure that I had the C stuff in there, the CMake stuff in there. And if you read this on, they have a list of things you need to have in order to start doing this. The build system. So you scroll down, structure, higher level, runtime support, hardware support libraries. I wish they would put this a lot earlier. No, it's not quite the right PDF, actually. There's another one from Pico. Yeah, it was definitely this Pico, this one. Yeah, this one. Blah, blah, blah. Dismiss, go away. So we had to do stuff like this. So they have 2 methods of installing this. And one of them was a shell script and another one was manually doing it all. Now the shell script will do all these things for you. Now I already had OpenOCD installed. I already had, let's say, Ninja installed. I already had CMake installed, right? But they had a recommendation for some other stuff to install. If you go down to the manual steps, so they walk you slowly through it. Install the tool chain. I already had that. I kind of had that. I didn't have the SDK, so I ran the script and it went and got a whole bunch of stuff. Yeah, see here, install the required Visual Studio Code, see Chapter 7. Okay, so let's go here. So these extensions right here. I already had this guy because that's just part of the C++ stuff, right? I already had the CMake tools. What I didn't have is the Cortex debug, which was this guy right here. So I had to add that. I did add the ARM assembly. And of course I already had autoconf and stuff like that. I'm not sure how I got that one in. I don't think it matters. Um, I mean, some of these are brought in by other plugins that you do. I think when you did the Cortex debug, it brought in some of these other ones like RTSO views and memory viewer and stuff like this, right? So once I had their extra ones in, um, sorry, one thing to watch out for is their shell script will create a directory called Pico already for you. So if you created a temporary directory or whatever, a directory to hold all this stuff in, you'll be one deeper in it, which was happened to me too. So what I did is I just erased my work, and in my work directory, I ran the shell script from there. It created Pico, and inside Pico, it created all the components. So, and it creates almost all this. Now, Arduino Pico I added later, and the project folders I created to hold the stuff I was going to build. And this guy I added from a recommendation in in the docs. There was a thing about this. We'll see it in later. So once I had all this created, and it actually goes and creates a custom copy of OpenOCD. It creates a bunch of stuff like this. But in the OS level, you'll still be missing a couple of parts. And one of them, of course, is GDB multi-arch. So you need to install that, app install GDB multi-arch. I think I might have it here. Control R apt. Control R. Yeah, I had to install Python 3 TK also. And zlib1. Had installed these guys. Had installed that. Had installed that. When I was building the OpenOCD, I added a couple of things to it so that I had a couple more of my debuggers supported. You don't have to do that if you're just using this one. But after adding all those missing pieces, I was ready to go. And the first pass I did it was all working, but the next time I was working with it, Ninja got in the way. So what I had to do in here is specifically say which CMake generator I was going to use. If you don't, you end up sometimes using the wrong one. And then it'll complain and complain and complain. So you can go to your settings, the GUI version, or you can just go to your settings.json file within the project. This VS Code, then settings JSON, and I end up adding the line CMake generator. This stuff after this I'll talk about later, but we'll get there. It's a lot of stuff to cover. So once I had all the parts in, I could actually then load up a project. So in order to create one, there was a lot of manual steps. I had to create a subfolder, I had to create the C file, I had to create the build directory, I had to run CMake and all that stuff. And this is where this documentation about this one, creating a standalone. So if you do create the project from scratch, it's a lot of pain. You have to do all this stuff here. Instead, if you keep scrolling down in here, right? Remember, this is Windows oriented, so you're going to see some Windows commands in here. Now, this talks about if you use Visual Studio instead of Visual Code. It's very close to the same thing. But no, I kept scrolling down, build a VS Code, blah, blah, blah. I did all this already, and it worked. And then when I got to the very bottom, I think it's in here. Yeah, right here. Create a project with the project generator. Let's skip a huge chunk of reading and just do this. So what you do You go in the command line and you say, so there's your projects, right? My Blink and a test project. But you can go like this, because I installed that one directory back, right? You give it a name. I could say Blink 2, for example, right? I didn't bother with any of this because I was just doing the Blink test program, right? But I said run a build, override an existing, create a VS Code project, and then in here, we're actually, you could use PicoProbe, or you can do this, or you can do this. Anyone actually technical will work, right? And you say okay, and you say okay, and you say okay again, and you say quit. Now, if I have a look here, there's Blink 2. And if we look in Blink 2, everything's built for you. Your CMake stuff, your directories, the VS Code stuff, all is done for you. So you don't actually have to do anything. That made things a lot easier. So once I learned how to build a Pico SDK project, right? And I'll just shrink this window for a sec. So here is my Blink program, and I could build it. Need a little more of this. Okay. Now it's important that you'll get an error from here if it thinks one of the parameters for CMake is not set yet. So this guy here is the CMake icon. So what you want to do is say, oh, under folder, what are we doing? Well, we're doing the Blink project. What's the compiler chain we're using? We're using of course, the ARM compiler chain, right? For debug, are we having debug or no debug, right? Well, we're just having generic debug, right? For build, what are we building? The Blink executable? Yes. For test, I didn't try this stuff out because you need test harnesses and stuff like that. And we have none of that yet. Mr. Debug here. Now this Mr. Debug doesn't work. It's because the debug from CMake runs the wrong launcher. So if you actually go in here, you can actually say yes, Blink is the one I want to debug, right, like this. But if you actually try to run the debugger, it'll just die and quit. And it'll come back with a really dumb error about failed controlling terminal, blah, 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 right? Because it's running the wrong debugger. Okay. And then, of course, you can set the launch one, but I haven't used that really yet. So if we go back to our code here, I don't need to be in the build directory. I was at this stage. I could build. Now, I wanted to upload. Now, how do you upload to a Raspberry Pi Pico from here? Well, it's not built in. The instructions are here in the instructions page, right? You can go back up here into the instructions and see how to upload. And it is in here somewhere. Building. It's either in this doc or the next doc. But anyway, how do you upload? Well, you can use the Open OCD tool to do that. And so in here, back to here. So this is the command line for actually doing it. We're using the debug interface. The target is in our Pico. The speed is 5K. The program to build is build blink elf verify reset exit. If you do this, that's what it usually happens. But if you get this sort of error in here, it means this is couldn't find blink, for example. So since we were just in project, we need to be in one directory deeper. There you go. So it uploaded our thing, and you can actually see it is blinking. But how do you do it within Visual Studio Code? Well, it turns out I had to add a bunch of extra stuff in. Besides tweaking the settings JSON for its crap here, I ended up adding a bunch of paths in here. Like so. There was another one in here that was, I think it's in the launcher, that was wrong also. Yeah, right here. By default, they had server type open OCD, and they didn't set the server path. So by default, it was going home, willm, work, Pico, open OCD, and then it was complaining it couldn't find the binary because technically the binary was in one more subdirectory source. But it didn't set that way. So that took a couple hours of fiddling to figure out where I was getting from. But I knew I had, open OCD sitting there right there, right? It was available to it. It just, for some reason, it was looking in the wrong spot for it. So from a forum post someone put in, just to add this into here. And sure enough, as soon as I did that, the problem went away. Now I could build and whatever, but I still couldn't upload. And there's still another flaw in the CMake, the debug button. It doesn't work. By default, CMake's debug doesn't pick the Cortex debug stuff. It just picks its own internal stuff and doesn't do anything correctly. What I had to do was I modified the launch. I renamed it from Cortex to PicoProbe, added some function into it like this, server path. I added the live watch stuff that was recommended, right? And basically that was it. And then it shows up down here. Now the first time you run this, let me just exit this and I'll see if I can trigger this. Yeah, okay. So you can see down here, it just says CMake debug ready, right? But if you click this, it'll ask you, okay, I want to debug, right? And that's it. It doesn't do anything. So if we click this debug button over here, it doesn't work. You get this error about this, right? But now this shows up, the Cortex one. And if I click that one in PicoProbe, we are now debugging. And you can actually see on here, it's telling us we're in a debug mode. And you see the blink is stopped. Now, if we go over here and we say, what is it, F9, set a breakpoint? Yeah. So we'll rerun this. And then we'll step down one. And you can now see that I stepped up to the point where I set the GPIO pin for the light. The light is actually set. And if I step again, it does the time. I step again, turns the light off. So we are stepping through the code in the Pico itself, right? And it works. But being me, I wasn't quite happy with this where I have to click 2 mouse buttons to make things work. right? So I looked up on Google and I found a plugin. Hey, there's always an extension to figure anything. And it was called, let me find it here, task buttons. So what you want to do, right? Oh, is it this one? Not quite. I wanted a task for upload first. So, because I didn't like going to the command line. So what you do is you write yourself a tasks JSON file. And you put the task in. I found a place where I had to cut and paste in it. The only thing I had to fix was this line right here, the build. So by default, it was wanting to build build main.c, or sorry, elf. Like that's the one it wanted to upload, and that's not correct. So I borrowed a line out of the CMake one where this determines based on the build path and stuff like that what the output is, and it worked perfectly. So if you put this in here and just took out their stuff in here and left the rest in it, it worked great. So now I actually have a button here called upload. And the way you do those buttons is you go back to your settings again. And right here, they have a code sample. I just cut and pasted it and trimmed it out to what I wanted. I didn't want the show task buttons, how many there were, so I turned it to off because by default, apparently it's on. And then I said, okay, I defined a task. I defined a label for it. That's the up arrow icon, word upload. The task, it must be case sensitive and match exactly the tasks. So if you go into tasks, if it doesn't match this, it won't find it. And then a tooltip for it. So if you put your cursor on it, upload the build task, whatever, it doesn't really matter. I should actually change this. Maybe I'll call it upload to the Pico. Now when I put a tooltip over it, there we go. Right? So now I can click this button. Ta-da! One button click for uploading. That left the debug one. And then I realized someone else pointed out that when you go to this icon here on the side, oh my God, I just didn't show you all this, did I? Okay, sorry. Backtrack here. So this code here defines the button. This is the button I was talking about. When I click it now, it uploads and builds. Sorry, it builds and uploads. Now I wanted to do the debug, and if you click this guy, I have to click off the menu. If you go to here and you're in this and you pick this, this will run the wrong debugger. It'll pick all these, but did you see the Cortex one or the Pico one? No, it's not in there for some reason. But if you go to here, this list, besides the default CMake debugger, add a configuration, I have the PicoProbe in here because I created a launcher for it. So it actually shows the launcher. And if I click this green button here, ta-da, one click shot. And everything is working. Now I tried this whole thing out with the Arduino framework in Platform IO, but I ran into some issues. I got it all working in Platform IO because it has its own uploader and everything, and it effectively uses OpenOCD to do things. But it was debugging the wrong code. It kept opening up the code before the code, so to speak, like actual raw Arduino framework code, not the actual code that you're working on. And I haven't figured that out. But I do have it working. So I would as I said, get started with this. Not only the standalone project one, but debugging Pico projects using the Pi debug probe in VS Code, and reading up from Raspberry Pi themselves how to get the environment set up. So knowing what is. Now, there was another problem with physical, okay? Let's find it here. No, it's in the debug one. There was a picture of this in the debug one. Doink, 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 doink. Let me just find it. Very misleading. No, it's... Sitting on the Raspberry Pi. Oh, I didn't know they talked about it in here. So I never got this far down in the docs. So, oh, damn it. No, it's not any of these. Where the heck is it? Solo project, debug. Is it you that have the bad picture? Yeah, you had the bad picture. So they make the assumption, of course, of the Pico H, right? But they don't tell you exactly how to do this with the other cable. And they're also not clear on the Pico itself, unless you root around for it, what the frickin' 3 pins are in what order. So you don't read them on the top here. Here, you have to flip it over. So this pin right here is clock. This pin right here is ground. And this one is SWDIO. Okay. So you're looking at, let's say, the box here, and it says, you know, the orangey red wire is TX/SC output from probe. Middle one is ground, and the yellow one is RxSD input probe or IO. Right? Well, why don't they just write in here slash the actual pin names of the Pico? No, they didn't bother doing that. So at first when I was doing this, I had the yellow on the wrong side and the orangey red one on the wrong side. So of course I wasn't talking to the thing properly. Right? And of course it's a double catch because you're just learning how to get this to work, and you have this backwards, and you're mislooking at the wrong errors because you're thinking you blew it up. But in reality, this might have been working, just this wasn't connected. And yeah, some system in articles and stuff like that talked about this, and they said if you see this block showing up when you build, I can't remember where it shows it, terminal. Yeah, right here. If you see this sort of chunk right here, it means you're talking to this. Talking to this part comes later. That's where this stuff happens. So if you don't see that's this stuff, but you do see this stuff, you have half of it right. You got this part working correctly, you just don't have this part working correctly. But I'm still reading through some of these docs and understanding it. As I said, this is a Windows-oriented version of it. So this is what I stole from them, this upload script for to make a task. And this right here was wrong. This assumes that that's what your output always is, and that's not the case. If you're creating a project and you're naming it something, the elf generally is the name of the project, right? So blink was the project, blink.elf was the output. And of course that doesn't work. So that's where I substituted that line in there, and it worked fine after that. And then this is their launch code. This is where I got the this from, the server path from. Now, this is the Windows one. The Linux one uses GDB-multi-arc. Windows uses the ARM-None EABI-GDB. So I guess on the Windows one, they broke out the GDB for every architecture. So you would run the appropriate GDB of the appropriate architecture. In this one, I guess GDB-multi-arc is capable of understanding a lot of architectures all in one. So I think ours is a little more cleaner. And I took this out too. We don't have this. And I wasn't using the XPack Open CD install. Why? This is stupid. If you're going to run the Raspberry SDK install, it's going to build an Open SOCD for you. It's going to be in the directory for you. So, which you can see right here. You just have to know that here, and then here, there's the program right there. Or if you don't want to use this one, which is effectively 0.12 version, it's the same one. Just make sure the path in that thing can get the system one, i.e. the one that's actually available in the system. We go here to terminal. Bash. And we say, where is open OCD? So user local bin open CD, right? But I could change the path in there and directly specify the Raspberry Pi's version of it. But there was no need. But that's debugging C++ stuff on the Raspberry Pi using their SDK. It took a couple of days for me to get all this straight. And I'm still not 100%. So I'm still reading parts of the documentation and amending my knowledge on this. In theory, this debugger is not restricted to the Pico. It is what they call a DMS or whatever standard style debugging probe. Like it follows the standard. So you can actually probably use it for other things. I think maybe the next debugger I might tackle is the Atmail one. I got a few different ones in here. Programmers, there it is. So we have all these programmers in here. I did see OpenOCD knows how to talk to this. It knows how to talk to a lot of these ones. So this is the, if I remember correct, this is the actual official ESP programmer for the ESP stuff. This is just a breakout for SWD. And this is an Atmail programmer. Actually, an ST-Link one. That was the Atmail one. No, it's the ST-Link one. What do we got here? This is the Sager one. This is the one I actually had to add support into this. This is the one I use to program the retro chip tester. These are these ones. This is a WCH programmer, I2C mini, I2C breakouts, SPI breakout, USB to TTL, ST-Link V2 programmer, serial converters and stuff. This is like the AT Tiny programmer. I know one of these things does Atmel. I just don't know now which one it does. I have to read up. So most of the bottom ones conversions are TTL to USB or whatever, different variants. I'm pretty sure I could use one of these guys to be an Atmel programmer because that's what I use to program the retro chip, and it's basically an Atmel 386, 128 times 2, 356. I can't remember what it was. And this is one. I think this one is more or less almost a universal. I'll have to try that one out. That's my spare Raspberry Pi one. I always buy two of everything just in case I blew things up, which I did actually. I blew this up. I wrecked it. But luckily, there was a GitHub page updating the firmware on the debug probe. And this happens to be the link to the current debug probe. Because inside of here's the probe. You think this UF2 file that they generate in here? Is PicoProbe.uf2? Nope, not correct. This what blew it up. When I dropped that on place on the thing, it died. I had to get this one off the website. I should actually add this Git repo to here so that I have access to it. So, git clone paste. Oh, it's quite a bit in the documentation. I think this actually contains all the PDF sources and everything else for it. But I'll add it to my collection. I got space. Well, it's working on that. As I said, I did get the Arduino side working too. That's why there's that subfolder in here called Arduino Pico. And it allows you to use the Arduino core instead of the stock core. Yeah, the one that the Raspberry Pi comes with. Sorry, Picos come with. Are we done yet? Ooh, no. I think there's a lot more than. We're about halfway done, looks like. Well, on this one, 32,891 objects. There we go. There we go. So now if we go to documentation, according to the website, it was documentation, ASCII doc, microcontrol, debug probe, updating firmware. So where is it actually getting it from? Uh, Raspberry Pi, PicoProbe. Let's go get this one too. I'm not sure it's going to override my existing PicoProbe tab, just in case. There we go. Well, that's strange. Interesting. It's not actually in there. It's in another piece. That's just me lacking understanding on Git. touch notes. There we go. I now have that link saved. I don't need it anymore on the website. Don't need that link. Don't need that link. Boy, did I open a lot of links for this. But that's so far I've gotten on this. It is working. So hopefully you might make sense of this. If not, just ask questions. I can go into details in particular areas if you need to. So I'll let you go.